Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, hope you all are doing well. We are going to start fuel and combustion. The main course outline for fuel and combustion is here. First of all, we will see what is the objective of this course. Why we are studying this course. To give an overview of different fossil fuels, students should be able to understand the significance of combustion in process industry. What is the significance? What is the importance of combustion in process industry will be studied. After this course, students should be able to design industrial furnaces and boilers. So this is the main objective for what we are studying this subject. Here is the course outline. In course outline, classification of fuels, chemical composition and chemistry of fossil fuels, physical chemical properties of fossil fuels such as density, volatility, viscosity, ignition, calorific value, pour point, cloud point and flash point will be studied. And combustion phenomena of common fuels, ignition and flame stabilization, detection, monitoring and control, practical application of fuel and common technologies, combustion generated pollutants and control, new fuels, fuel testing and specification of commercial fuels, calculation of composition of products from combustion of gaseous, liquid and solid fuels, flue gas analysis, proximate and ultimate analysis, heating values of fuel, lower heating value as and higher heating values, advantages and disadvantages of gaseous fuels, combustion of hydrogen, carbon, hydrocarbon and sulfur, air to fuel ratio, losses in burning fuels. So these are the topics we are going to discuss. In lab we will perform the following experiments: fuel analysis, flash point, fire point, calorific value, combustion characterization, combustion emissions and combustion efficiency. So this is the basic theme of this subject, what we are going to study in this subject. Now next is, first definition is, what is fuel? Fuel is any material that can be burned to release thermal energy. Fuel could be anything which burns and give energy. Most familiar fuel consist primarily of hydrogen and carbon. Most fuels consist of hydrocarbons, as you know, as petrol and other fuels contains carbon and hydrogen as an essential element. They are called hydrocarbon fuels and are donated by the general formula. So this is the general formula of the hydrocarbon fuel. Hydrocarbon fuels exist in all phases. ठीक है, it could be solid, it could be liquid, it could be gas. Some examples being coal, gasoline treated as octane, usually known as octane, and natural gas. So as you know, coal is a solid, gasoline or petrol is a liquid and natural gas is a gas. So fuel exists in all the states, all the phases: solid, liquid and gas. Next is, what is combustion? So this was fuel, and combustion is a chemical reaction during which fuel is oxidized and a large quantity of energy is released. Fuel is a material which consists of hydrocarbon and is burned to release the energy. The process of burning or oxidizing is known as combustion. So combustion is a chemical reaction during which fuel is oxidized and a large quantity of energy is released. The oxidizer, now the oxidizer most often used in the combustion process is air. You know, for combustion we need three things, three material basically. Here is the fire triangle. This figure is known as fire triangle. So for fuel, for burning, for combustion we need three things: oxygen, fuel and heat. If any of these any one of these goes, then no combustion will happen. Okay, these all three things should be there to perform combustion: oxygen, heat and fuel. Fuel, as you know, is a hydrocarbon, heat is ignition source and oxygen is what we take from air. It is stated the oxidizer basically the thing which oxidizes the fuel. Oxidizer most oftenly used in the combustion process is air, which is air. Most probably, as you know, that in combustion air is used and we do not use any other source of oxygen on a mole or volume basis. ठीक है, it could be on mole basis, it could be on volume basis. Dry air is composed of, now this is the composition of air. 20.9 dry air, 20.9% oxygen, 78.1% nitrogen, 0.9% argon, and small amount of carbon dioxide, helium, neon, and hydrogen. So these are present in small amount. So usually we take 21% oxygen and 79% nitrogen for our calculations. The fuel must be brought above its ignition temperature to start combustion. If we want to start combustion, then we need to bring the fuel above its ignition temperature. Ignition temperature is the temperature at which fuel starts burning. Okay, the temperature at which fuel starts burning is ignition temperature. So we need, for combustion we need to brought the fuel above this temperature, above ignition temperature, to start combustion. The minimum ignition temperature in atmospheric so the maximum ignition temperature in atmospheric air are approximately 260 degrees centigrade for gasoline, 400 degrees centigrade for carbon, and 580 degrees centigrade for hydrogen, 610 degrees centigrade for carbon monoxide, and 630 degrees centigrade for methane. This is the ignition temperature, minimum ignition temperature at atmospheric air. Now this is these are the two diagrams showing combustion process. First one, the mass shows that the mass of each element is conserved during a chemical reaction, means that mass in is equal to mass out. How much reactants are present here will be in the product also. For example, here is 2 kilogram of hydrogen, and the second element is oxygen, which is 16 kg. For combustion, after reaction, the product will form also contain 2 kilogram hydrogen and 16 kilogram of oxygen. Here is another diagram which shows that in a steady flow combustion process, the components enter the reaction chamber are called reactants, and the components that exit are called products. As you know, if there is any reaction happening, the components which enters the reaction chamber or reaction column are known as reactants, and the components leave the reaction chamber or reaction column are known as products. Here is the example: carbon plus oxygen, sign of arrow, CO2 or carbon dioxide. So here carbon plus oxygen are the reactants and carbon dioxide is the product. Okay, now moving towards air to fuel ratio. Air to fuel ratio is defined as the ratio of mass of air to the mass of fuel for a combustion process. Okay, mass of air to the mass of fuel is known as air to fuel ratio. Mass of air divided by mass of fuel. Now this mass could be calculated by this formula: m is equal to n m, where m is mass, n is number of moles, and m is molar mass. So this m can be calculated by this formula. Proportions of the fuel and air must be in the proper range for combustion to begin. This is an important thing. Air to fuel ratio must be in a proper range to perform combustion. If air becomes low, there will be no complete combustion. If air quantity is high, then also there is a problem for burning or combustion. So a proper ratio or proportion to air to fuel ratio is required for combustion. For example, natural gas does not burn in the air in the concentration less than 5% or greater than about 15%. So this is the one example that natural gas will not burn if the concentration or air to fuel ratio is 5% or greater than about less than 5% or greater than about 15%. If this air to fuel ratio lies in this pattern, then there will be no combustion of natural gas. The air to fuel ratio represents the amount of air used per unit mass of fuel during combustion process. So what is air to fuel ratio? Air to fuel ratio is the amount of air used per unit mass of fuel during a combustion process. Means that how much air is used for a unit mass of fuel. Now here is a diagram. Fuel 1 kg, air 17 kg enters to the combustion chamber, and here products of 18 kg, 17 plus 1 18. As you know, we have previously discussed that mass of each element is conserved, means that mass remains same. Okay, how much reactants in is equal to the products mass of products out. Mass of product in is equal to mass of product out. So this is air to fuel ratio. I think this is enough for today. Now we will end up. See you in the next lecture, inshallah. If you have any question, you can comment me and I will answer you. Thank you. Allah Hafiz.